Alright, let's take a look at question 2. In question 2, we're being assessed on how to expand binomials. Okay, we're going to be expanding binomials raised to the second and third power. We're going to be using the distribution of fold method and the Pascal's triangle to expand these binomials, and also the box method too. Alright, so question 2 reads, which statements are true for all real numbers? So let's start with statement 1, expand that and see if it's true or false. Then we will advance to statement 2. Alright, so let's start with statement 1. The question is x minus y quantity square equal to x square plus y square? Is it? So what we're going to do is we're going to expand the left side and see if it equals to the right side. Okay, so expand x minus y square. So x minus y square just basically means you're multiplying x minus y by itself. If you know the formula, you can do this real quick. A square minus 2ab plus b square. You apply that here, and you can mentally compute the expansion of this binomial as x square minus 2xy plus y square, which is different from that and is false. So let's act as though we don't know that trick. We're gonna multiply it out. Alrighty, so first, outer, inner, last. That's how you multiply two binomials. When you carry out the multiplication, you are going to get first x times x is x squared, x times negative y is negative xy, negative y times x is negative yx. Multiplication commutes, so you can also write that as negative xy plus y squared. Okay. If you combine the middle terms, you're going to have x squared minus 2xy plus y squared. Ladies and gentlemen, is this equal to x squared plus y squared? The answer is no. This is false. Alrighty? So it cannot be option 1. Now let's take a look at option 2. Option 2 states is x plus 3 raised to the third power. Is it equal to x to the third plus 3xy plus y cubed? Is it? Well, let's see. What we're going to do is we're going to go ahead and expand the left side, since the right side is already expanded fully. So expand that. Okay, so x plus y to the third is x plus y times x plus y times x plus y. Okay, raising to the third power means you are multiplying by itself 3 times. Alright, so let's go ahead and carry out the multiplication. We'll do it 2 at a time. Alrighty, we are going to multiply the first 2 first, and then multiply the resulting product by the last binomial. Alright, so when we follow that out, first, outer, inner, last, we're going to have x squared plus xy plus xy plus y squared, okay, times x plus y. And then we can combine the middle term here, positive xy and positive xy. When we combine those, we are going to have x squared plus 2xy plus y squared times x plus y. Okay, now we're going to multiply this trinomial with this binomial here. Whenever I'm multiplying with polynomials with 3 or more terms, I like to make use of the box method. The box method helps me stay organized, and it reduces the chances of making mistakes. Okay, so let me show you the box method. You don't have to use it. You can just distribute. Alright, whatever method you like. So I'm going to use the box method here. So it's just a multiplication grid. Alrighty, so I have 1, 2, 3 terms there. So just break it down. 1, 2, 3. Oopsie. 1, 2, 3, and then 2 terms here, like that. Okay, so we're gonna put the first factor on the top. So x squared, this x squared column, 2xy. This is 2xy column, and then this is y squared. They all positives, okay? So don't put the sign. And then x plus y, just put an x here, and then positive y down here. Now, let's multiply. X times x squared is x to the third. X times 2xy is 2x squared y. X times y squared is xy squared. Y times x squared, we can write that as x squared y. Y times 2xy is 2xy squared. And then y times y squared is y to the third. Alright, team? Now let's go ahead and combine like terms. We have x to the third has nothing to combine with, so we just bring that one down. So the product is going to be x to the third. And then let's see. 2x squared y and x squared y are like terms, so I can combine these two. So x squared y has an invisible coefficient of 1. When I add these two together, I will have what? Positive 3x squared y. Okay? And then xy squared and 2xy squared are like terms. I can combine those together too. So 2xy squared and xy squared are like terms. I can combine them together. This also has a coefficient of 1. So 2xy squared and xy squared can be combined to give you 3. So positive 3xy squared. And then the last term is y to the third. So plus y to the third. And that's your final answer. Okay, we can't combine these two because we have x squared y and xy squared. Is this equal to x squared plus 3xy plus y cubed? The answer is no. This, ladies and gentlemen, is false. They are not equal to each other. Alrighty, so neither statement 1 or 2 are correct. Alrighty, now the method that I use right here is I just multiplied out. Okay, multiply out. There's another method which I prefer, which is faster if you know how to use it, to expand binomials of higher powers. Okay, if you have a binomial raised to a third power or higher, you can use the binomial theorem or Pascal's triangle. Alrighty, the one and the same thing. So I'm gonna show you how that works. So we're just going to do this multiplication again, expand x plus y to the third. But what we're going to use this time is we're going to use Pascal's triangle or the binomial theorem. Okay, binomial theorem. Alright, so let's see how that works. So we're trying to expand x plus y to the third. So we're going to use Pascal's triangle. We're going to the third power, so we're going to generate Pascal's triangle up to the third row. Alright, so starting with row 0 is 1, 1, 1 for row 1, 1, 2, 1 for row 2, 1, 3, 3, 1 for row 3. Okay, remember you always start from row 0. So Pascal's triangle is generated by putting 1 at the ends, and then you add the two numbers on the top to generate the bottom middle number. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3. Bam. Okay, so these represents the coefficients. Okay, part of the coefficients, but in this particular case it actually is a coefficient. So I'll take these numbers right here, the third row of Pascal's triangle, 1, 3, 3, 1. Some of you already have this memorized, and I'm going to line it up. So we have 1, 3, 3, 1, and then I'm going to take these two terms and multiplying x and y. So I'm going to have x, 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 x. Alright, so 1 times x, 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 and then times y, times y. This is just a different way to expand binomials. Okay. Alright, now I'm going to put in their powers. The x is the first term, so it starts with all the power, and this starts with no power. And then the power of x descends to 0. Okay, so 3, 2, 1, 0. Alright, and then the power of y ascends from 0 to 3. 0, 1, 2, 3. So just multiply these out, add them up, and that will be your final answer. Alright, team? So for the first term and last term, the terms with the 0th power are going to be 1. So y to the 0th power is 1, and x to the 0th power is 1. Okay, so let's multiply them out. Okay, so 1 times x to the 3rd times 1 is x to the 3rd. And then 3 times x squared y is 3x squared y. 3 times xy squared is 3xy squared. And then 1 times y to the 3rd is y to the 3rd. If you add them all together, you get x to the 3rd plus 3x squared y plus 3xy squared plus y to the 3rd. And that's exactly what we got here. X to the 3rd plus 3x squared y plus 3xy squared plus y to the 3rd. And we see that it is not equal to x squared plus 3xy plus y to the 3rd. Alright, so this is just a different way of expanding binomials. Whichever method you use, you can clearly see that neither 1 nor 2 are true. Alright, so question for you. Which method do you prefer for expanding x plus y to the 3rd? Do you prefer just multiplying it out, or do you prefer the Pascal's triangle / binomial theorem? Let us know by posting your vote in the comment section below. Okay? For taking the time to watch this presentation, really appreciate it. We'd like to know what you think about this review tutorial. If you found it helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just post it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our channel for updates to the remainder of this review series. More support resources can be found at Mathgotserved.com under New York Regents. Thanks again for watching and have a wonderful day. Goodbye.